So good morning, chemistry second year, English medium, unit is organic compounds containing carbon, hydrogen, oxygen, then topic is preparation of alcohols. In the previous class, so we discussed the preparation methods of alcohol, just two methods. Okay, then from alkenes, second one is here is a Grignard reagents. Okay, so how can we prepare? Here is a Grignard reagents. How can we prepare the alcohols from Grignard reagents? Let's see. Okay, then by using Grignard reagents, by carbonyl compounds, we can prepare the alcohols. Okay, yes. How can we prepare alcohols from Grignard reagents? Let's see. Then Grignard reagent means what? Alkyl magnesium halide. Alkyl magnesium halide is considered as Grignard reagent. Then the alkyl group present in Grignard reagent act as nucleophile. Okay, whereas when alkyl group present in alkyl halide, it act as electrophile. But yes, here is in Grignard reagent, alkyl group act as a nucleophile because it is adjacent to the magnesium. Then yes, when compared with metal, the carbon is having high electronegative. That's why the bond pair is polarized towards carbon. That's why alkyl group act as a nucleophile. Yes, when this nucleophile interact with carbonyl compound. Carbonyl compounds, general formula is CO. Okay, yes, bond CO. Then next one, alkyl carbanion interact with the carbonyl compounds. Yes, at the carbon center, here is an electron deficiency. Electron deficiency is generated because this carbon is connected with a highly electronegative atom, oxygen. That's why the nucleophilic addition takes place here. Okay, carbonyl compounds involved in nucleophilic addition reactions. Then is the alkyl magnesium halide can supply the nucleophile. So nucleophilic addition takes place. As a result of that, yes, here is a adduct is formed. Okay, it's a adduct. In this adduct, here is a carbonyl compound and a Grignard reagent is there. Then this adduct undergoes hydrolysis. Then here is a alcohol is formed. Okay, so this is the alcohol. The next one is magnesium hydroxy halide. Then yes. So let's take the examples for Grignard reagents. That is a methyl magnesium bromide. Methyl magnesium bromide when interact with formaldehyde. Formaldehyde is also here is considered as what? It is a carbonyl compound. Okay, very primitive carbonyl compound. Then yes, methyl carbanion act as a nucleophile. This nucleophile interact with the carbonyl carbon. Then yes, again here is Grignard reagent and formaldehyde adduct is formed. This adduct undergoes hydrolysis with water. Then here is a ethyl alcohol is formed. Ethyl alcohol, this is called as primary alcohol. Okay, the primary alcohol. This is hydroxyl group is attached with primary carbon. That's why it is a primary alcohol. Then next one, when Grignard reagent interacts with acetaldehyde. Then so here is what again here is adduct is formed. This adduct undergoes hydrolysis. Then isopropyl alcohol or is a secondary alcohol is formed. So its IUPAC name is propane 2-ol is formed. Okay, propane 2-ol is formed. Then next one, when Grignard reagent interact with the ketones, that is acetone here. Then so again here is a nucleophilic addition. So methyl carbanion act as a nucleophile. This nucleophile yes attacks on the carbonyl carbon. Nucleophilic addition takes place. Then as a adduct is formed. This adduct undergoes hydrolysis and forms the tertiary butyl alcohol. tertiary butyl alcohol. So it is a tertiary carbon. This carbon is connected with the 3 other carbon atoms, then that is why it is a tertiary. This tertiary carbon is attached with OH hydroxyl group or alcohol. That's why this is a tertiary alcohol. Its IUPAC name is then 2-methyl propane 2-ol. Okay, so this is about the preparation of alcohols from Grignard reagents. Simply, Grignard reagent is nothing but what? Alkyl magnesium halide. Alkyl magnesium halides gives the alkyl carbanions. Okay, then yes, here is formaldehyde. Formaldehyde gives the, here is a primary alcohols. When Grignard reagent interact with formaldehyde, then here is a primary alcohols are formed. Except formaldehyde, remaining aldehydes when they interact with Grignard reagents, then secondary alcohols are formed. Then yes, is the ketones. When ketones interact with alkyl magnesium halides, that is a Grignard reagents followed by hydrolysis, tertiary alcohols are formed. Tertiary alcohols. Primary, secondary and tertiary alcohols can be synthesized by taking Grignard reagents. Okay, Grignard reagents. Just when Grignard reagent interact with only formaldehyde, then primary alcohol. Except formaldehyde, remaining all aldehydes when interact with Grignard reagents, secondary alcohols are formed. Then yes, when Grignard reagents interact with ketones, tertiary alcohols are formed. So this is about and second method of preparation of alcohols. Then third method is what? From carbonyl compounds. So we can use the carbonyl compounds to prepare alcohols. How? So this is the aldehyde. So this is a ketones. Okay, when aldehydes and ketones undergoes the catalytic hydrogenation. Catalytic hydrogenation means what? So we are taking nickel or palladium or platinum. So these metals are taken in. So these metals are taken in the form of in the form of what? Is a grinded form, that is a powdered form. Then these are having the more surface area. Then yes, here is a when these metals used as catalysts. Okay, catalyst. Then yes, a catalytic hydrogenation. In presence of these metallic catalysts, then hydrogen interacts with the carbonyl compounds and forms the respective alcohols. Okay, yes, when aldehyde undergoes the catalytic hydrogenation means what? Adding of hydrogen. Catalytic means what? Catalytic means what? In presence of catalyst. In presence of catalyst, the hydrogen is added to the carbonyl compounds. If a carbonyl compound is aldehyde, primary alcohol is formed. If the carbonyl compound is ketone, then secondary alcohol is formed. Secondary alcohol. Okay. Then next one is carbonyl compounds. Carbonyl compounds can give the alcohols in presence of reducing agents. That is a sodium borohydride. Sodium borohydride is considered as a reducing agent. Then in presence of sodium borohydride, then aldehydes gives the primary alcohols. Then next one here is a ketones give the secondary alcohols. Ketones give the secondary alcohol. The sodium borohydride can give the here is what we are not adding, we are not using hydrogen gas here, just sodium borohydride. The sodium borohydride can transfer the hydrogens to the aldehydes and as well as here is a ketones. That's why primary and secondary alcohols are formed. Then next one, another one is by reduction of carboxylic acids. By reduction of carboxylic acids. Then again here is we are using a reducing agent, that is lithium aluminum hydride. lithium aluminum hydride. Lithium aluminum hydride can give the here is a primary alcohol in excellent yield when is a carboxylic acid is taken as reactant. Okay, carboxylic acid undergoes reduction in presence of lithium aluminum hydride. It is a strong reducing agent. Simply here is what alcohol is formed, alcohol. Okay, then when compared with sodium borohydride, lithium aluminum hydride is considered as strong reducing agent. Sodium borohydride only reduce the aldehydes and ketones, but not there is esters and carboxylic acids. Okay, esters and carboxylic acids ni reduce cheyaledu. Okay, then when compare with lithium aluminum hydride, sodium borohydride is weak reducing agent. Lithium aluminum hydride is considered as strong reducing agent. Lithium aluminum hydride can reduce the esters also. Esters can be reduced in presence of lithium aluminum hydride, then and forms the there is a alcohols. Okay, then esters and carboxylic acids can be reduced to alcohols in presence of lithium aluminum hydride. Okay, then but here is a lithium aluminum hydride is somewhat expensive, so due to this reason in order to convert the carboxylic acids into alcohols, first of all these carboxylic acids are converted into esters by interaction with alcohols in presence of acidic medium. Then simply carboxylic acids are converted into esters. When these esters undergoes here is a catalytic hydrogenation in presence of nickel or palladium or platinum, then simply here is alcohols are formed. Okay, so this is about preparation methods of alcohols. Okay, then from carbonyl compounds, simply aldehydes and ketones undergoes catalytic hydrogenation, then primary and secondary alcohols are formed respectively. Okay, then sodium borohydride also reduce the aldehydes and ketones to the respective alcohols. Then lithium aluminum hydride can reduce the carboxylic acids and esters to alcohols. Okay, then this is about preparation methods of alcohols.